have been anywhere in the world today, but you're here with us in Tel Aviv City. Are you ready for a Python talk? Woo! Yes. All right. Who's here for some NLP? Okay, great. Who's here for some networks? Awesome. And who's here for the bastard orphan, son of a whore and a Scotsman, and a groundbreaking musical about him? Yay! Okay, great. So this talk is for you. Everybody else, you can leave. So let's start with a bit of an exposition for those of you who aren't familiar with Hamilton. So Hamilton, an American musical, is a biographical musical written by this guy, Lin-Manuel Miranda, based on the 2004 Alexander Hamilton biography by Ron Chernow. Now, Hamilton was one of the founding fathers, the first Treasury Secretary, and a visionary. And I want to share my analysis here in a not so old-fashioned way about this musical. But let's start first with what we're not going to be talking about. We are not going to talk about how Hamilton himself dragged his behind all the way from Nevis to New York. We are not going to talk about how John Adams and Thomas Jefferson gossiped their way after he died and ruined his reputation. And we are definitely not going to be talking about how Martha Washington named her feral tomcat after him. That's historically debatable. But what will we talk about? So we will talk about how you can treat any corpus of documents to be treated as a graph, and each document is a node in that graph. We will be talking about how to properly model edges to find themes, and how Lin-Manuel Miranda created an amazing piece of art. But before we do that, I'm sure some of you are asking yourselves, yo, who the F is this? That's from the musical. Okay, well, my name is Tal. I'm a father of two smart and funny girls. I'm married to an OBGYN doctor. I have to read this because otherwise I'll forget. I'm a data consultant and educator. I'm also known as Analysis Paralysis. I started XP Lab. That is the only place in the world where analysts can actually practice real analytical problems instead of just querying. And a quick warning, this pixelated face, that's me. And it's important for me to tell you this because that's going to be a recurring motive in this talk. So I do apologize in advance. Now, the reason I feel comfortable and not extremely imposterish talking about Hamilton is because if we're taking only Spotify data, in a span of 6.5 years, I've listened to more than 10,000 tracks related to Hamilton. And yes, there are 100 שירים ראשונים there, a proof that I'm a father. Or has a weird sense of music. Now, Hamilton was a man of words, and so are we. So let's start with some natural language processing. Clear cut. So generally, I'm going to cover up some basic terms, okay, so that we can all be aligned and later analyze the songs of the musical. Now, we're going to be talking about pre-processing, tokenizations and engram, and TF and IDF. Okay, so let's start with pre-processing. Pre-processing, for those of you who aren't familiar with the term, is the step of cleaning and transforming raw data into structured, machine-readable form that models can actually learn from. We will use that to clean the lyrics so that we can find themes in them afterwards. So here are the opening lines of the musical, and pre-processing means removing all the punctuations, the speakers, double lines, etc. So we can get from this to this. And this is great because now we can break it down into tokens. Now, an important understanding about the term tokens. Tokens in our use case is just strings separated by spaces, okay? Unlike LLM tokens, which are related to the embeddings, and then a token can be a part of the word. N-grams. N from number, grams from the Greek word gramma, which is something that is written. And it's a method to capture needed context in a document, right? So if we break the first line into unigrams, we get how does a bastard, etc. And taking bigrams is going to be how does a bastard orphan, etc. Now, this is a musical, and we want to capture the full context, so we're going to use something a bit different. We're going to use maxgrams, which is the longest contiguous word sequence, okay? Two more basic terms, and we're off. The first one is TF, or term frequency. And term frequency is the number of times a specific term repeats itself in a document, okay? Or just the grade we're given for an in-document repetition. Now, if a term repeats itself a lot, that gives the grade, sorry, that gives the, if a term repeats itself a lot, it's more important than in the context of that document. So let's take a look at the literary masterpiece, Yuda Yuda by Asmachot, okay? And the relative frequency of the term Yuda within the document Yuda Yuda is 0.762. Yes, which means that Yuda is an important term in this song. Moving on to IDF, or inverse document frequency. It's the log of n over n of t, or just the log of all the documents that we have in the corpus over all the documents that have that phrase. And that means that the more frequent the phrase throughout the entire corpus, the lower the value of the IDF, okay? So again, example, if we take all the LinkedIn posts from the past 2.5 years with the phrase LLM in them, the grade for LLM is going to be very low, right? Because it's super repetitive. Okay, networks. Let's talk about networks. Basically, in graphs, we have two main objects. We have nodes, right? And in our use case, nodes are going to be songs, and we have edges, or the connection between any two songs. Now, graphs comes in two basic flavors. They come in an undirected graph and a directed graph. Let's go quickly over that. Now, an undirected graph doesn't have a direction or an order. I know that you know that because it's undirected. And this is kind of like Facebook, right? This is the common example. In Facebook, if I friend you, you are instantly my friend as well. And we will treat every song in the context of this musical as a green node. Okay? A green just for the sake of this one. Now, a directed graph has a direction and an order. And again, I'm sure you all know that, but this is kind of like Twitter. If I'm following you, that doesn't necessarily mean that you're following me. Okay. And the way that we'll use that is to show the progression of the lyrics. Okay? So if we take a look at both of those classes, the one thing that I find that is super important in this case is the weights, right? Or defining how strong a connection between any two songs is. But Tal, I hear you say, I don't hear you say that. How do we build a trustworthy graph? Okay. Good enough. How do we build a trustworthy graph? Meet Alexander Hamilton. Meet his son, Philip Hamilton. Now, in the musical, both of them have distinctive opening songs that they speak about themselves. It's My Shot and Blow Us All Away, right? And in both songs, I remind you, those are the nodes, the lines echo each other, right? King's College, I probably shouldn't brag, but dag, I'm amazed and astonished, and only 19, but my mind is older. Now that shows lyrical intent, considering that My Shot comes before Blow Us All Away. So what's the problem? Let's do that for any matching token, right? But what we'll do with the, that's not really useful, right? And it opens up a lot of room for noise. So let's define, for this use case, this right here, a minimum of 4 tokens just to have a connection. So these two nodes will have a strength that will be defined by this formula. Okay? Now this formula is just the sum of square of lengths of the phrases over the minimum length of the songs. So in our case, the strength of the connection between those two songs is 0.462. Okay? 3 common phrases that repeat themselves. Now, I have domain knowledge, I think I've established that, about Hamilton. And I know that there are some phrases that are less than 4 words. Some of them even 1 word, like non-stop or helpless. I told you that it's going to repeat itself. Or satisfied. So let's add that into the formula as a motive part. Okay? So this is the formula that we've seen before. This is the motive part. And basically, it's the sum of multiplications of the IDF of a specific term by the minimum of term frequency. I did not use ChatGPT to simplify that, as you can probably guess. Well, over the minimum length of songs. Now that means that for any two songs, we determine the strength of the connection through the strength of a general four tokens term and a motive part, okay? Now, cool. Just a quick note there. I chose 4 tokens just because. You can use 5, you can use 3. That's not the exact science part of it. So let's see the actual musical in a graph. I'm sure that we're all here for this. So a bit of explanation before we begin. Nodes are the songs, edges are the connections of the songs, and the width of the edges determines the strength of the connection. The size of the node is the overall income in weight, and the color is the clusters. I use the Louvain cluster to cluster those. Now, I want you to take a look at this undirected graph and sort of lock in your intuition about the songs. And let's start. So here we have King George III song. I know him, what comes next, and you'll be back. Next up, we have Alexander is in political trouble, cabinet battles, and meet me inside. Next up, we have Alexander is in lust-related trouble. We'd say no to this, and we know. After that, we have Alexander is in love, satisfied, helpless, balls, winter's balls, and some of the Reynolds pamphlet. People singing about Hamilton with non-stop, take a break, stay alive. Basically, people are telling him what to do. Then we have wartime songs with Yorktown, 10 dual commandments, and right-hand men. And here we have Washington is talking about history. One last time, history has its eyes on you, and the finale itself. Now, a cool thing that we can notice is those 5 songs there, right? Those are the standalone. Those songs don't belong in any of the clusters because they create motivations for the characters outside of the scope of the main narrative. Songs like Burn and Dear Theodosia, Washington on Your Side, and Farmer Refuted. Now, another cool thing that Lin-Manuel Miranda did is to refer and create connections to other musicals, right? So we have Sit Down, John is from the musical 1776. We have the model of the modern major general is from Pirates of Penzance. We have Nobody Needs to Know, and You've Got to Be Carefully Taught from those musicals, whatever they are. I know, not all musicals are born the same. We have, of course, Tomorrow and Tomorrow and Tomorrow, which isn't a musical technically, but it is from Shakespeare's Macbeth. And that leads me to looking at the progression of information throughout the musical. Okay? So let's see. This is progression. Let's consider the musical as a directed graph. So this is our graph. We want to take a good look on the main body of the musical, right? Only the main body. And we'll drop the nodes. We'll have these 5 songs. Now, these 5 songs open up the musical because they are not interconnected in any way between one another, okay? Let's take a look at the first act. All right, so this is the order. The colors are the same colors as before based on the clusters that we had. And the wider the edge, the stronger the connection. Now, what I like to see here is actually this part where the Schuyler sisters and Look Around are strongly connected, where the Schuyler sister, Eliza, is singing, look around, and how lucky we are to be alive right now. And she says the exact same thing to Hamilton, in That Would Be Enough. And I think that's really sophisticated in terms of songwriting. Next up, I love how everything sort of culminates towards the end of the first act. And if you look at the second act, we see 3 different stories, or 3 different strong stories, right? We have the life and death of Philip Schuyler. Woo. We take a break and stay alive reprise. You remember how she counts, Eliza is counting with him on the track, what I don't know French, for the life of me. We have the crime and punishment of saying no to this, and we know we've seen that in the undirected graph, but it's lovely to see that here. And of course, we have Aaron Burr's motivations, right? Where he wants to be in the room where it happened, and that leads him to the battle that he has with Hamilton on the obedient servant. Now, this is breaking the act separately, but this is the full musical, okay? And again, we can see how everything drives towards the world was wide enough and the finale. And I don't know how much time I have. I guess that I'm soon to be done. So I'd like to quote Hemingway that said that every man has 2 deaths. When he's buried in the ground and the last time somebody says his name. And in some ways, some men can be immortal. And it seems to me like it all comes down to, who lives, who dies, and who tells your story. Thank you very much. This is my LinkedIn. Feel free to scan it.